All right, round two. Let's do this. Number four, not P or Q. That's saying the P or Q. Remember, is saying that either P is true or Q is true. At least one of these two things is true. So saying not that means that it's not the case that at least one of these two things is true. So that's going to say that both of them are false, right? So this is saying both of them are false. Does that entail that P is false and Q is false? Well, yeah, that's just what I just said, right? So this one I'm going to say is probably invalid. Let's go ahead and write it out, though. We have not the case that P or Q, and then I'm going to see the negation of this. Let's see if we can have the negation of that. It's not the case that both not P and not Q. Is that true? Alright, so I am going to go first with the not or rule, and the reason is because it goes straight down, right? Not A or B means that you don't have A and you don't have B. It's not the case that at least one of these things are true, so both of them are false. So looking at here, it would look like not P, not Q, check. And then the next one is the not and rule, and that splits, right? It's saying this A and B is saying you have both of these, and saying that it's false means at least one of those is not false, is not true. So you split them out. So that's what this is, and we will split that out, and it's going to be not P, not Q. Notice it's not because this is saying it's not P, so, and you're saying that's false, the not P, so you're going to say not P, and of course not P turns into P, not Q turns into Q. Checkity check check. Now I look for contradictions. P and not P contradict, Q and not Q contradict. On both sides we have closed branches, valid. Alright, last one is number 5. P and Q and R entail R and P and Q. Yeah, that's, I mean, because this is saying, look, P and Q is true and R is true. Both of those things are true. And then when you look at this, what does P and Q true being true mean? It means that P is true and Q is true. So yeah, this is going to be valid. I already know, but let's do it anyway. So let's see what we got. Excuse me. P and Q and R. P and Q and R. Does that entail? Can we ever have? Excuse me. Can we have the negation of the conclusion? The conclusion is R and P and Q. Notice I have to have extra parentheses around here because I'm negating the whole conclusion, not just this first part. That's tricky right there because you have a parentheses right here, and we've been thinking, oh yeah, just put a not and then parentheses, but then that parentheses doesn't go around the whole thing. So I need a parentheses to say I'm negating this whole thing. Excuse me. So let's first do the and rules because the and rules go straight down. They're the nice and clean ones. So I have P and Q and R. Notice this is in parentheses. So what we've got here, this is like the A, and this is, here's of course the and this is like the B, right? So it's P and Q and R. Don't go first into the parentheses. Then you're gonna have no idea what to do with the and R over here. So we're gonna have to go, outside parentheses in like that. So let's do our first one. It looks like P and Q R check. And now I'm going to do this, and before I even do this, I'm going to finish this one off too because I know that one's clean. So I will write P, Q, check. Now the not ands look like, where are they? They fork out like that, right? If you, whatever this is, you negate that one, then you negate this one like that. Alright, so you have R and P right here, and you have Q right here. Again, outside parentheses in, right? So R and P and Q. So I'm going to fork that out and say not R and P and not Q, check. And then there's nowhere else to go with this, but I see already contradiction, not Q. So I'm good over here. I know that's I know that's a closed branch. And then I see the not R and P. Again, same rule I just pulled, which is this one right here. Right? Not A and B turns into not A, not B. Not R and P turns into not R, not Oh, sorry. Not P. I look for not R up here. Oh, there's a contradiction right there. Closed. Not P. There's P right there. Contradiction again. Closed. This is valid. And one last time, let me say it one more time what we're doing here. We took the premise, there was only one premise here, right? And we negated the conclusion. We said, is it possible to have the premise and not have the conclusion? If that's not possible, then we know that when you have the premise, you must have the conclusion. It's kind of like arguing backwards. And that's what we did. We said, here's the premise, but not the conclusion. Oh, that doesn't make sense anyway. So you have to have the conclusion. So we just proved that if you have this, then you do have the conclusion. And that's it.